Okay, what we've worked with before is net ionic equations, and we always did those with double replacement reactions. And in a double replacement reaction, the product that clued us in that we had the product of the net ionic equation was the one that was labeled with an S, or solid, also known as a precipitate. Okay, we're adding two new things today, the gas and the liquid. Okay, if you have, for instance, gas and solid, or gas and liquid, okay, both are going to go into the right side of the net ionic equation. So that's really good information, and you're going to see how it works. So here we are looking at what we did in the past. Okay, I wrote out the whole equation for you, and I balanced it, just like we did when we did the stuff from the lab, right? We did those things, mixed them all up in different ways, and wrote balanced equations. So this is a balanced equation. Now, what do we circle? Do we have that little thing? Let's put that in here too. I'm just carrying over the last screen, change the color so it stands out a little bit. And now you can see I'm looking for gas, solid, or liquid. What do I have on the right side that matches one of those? Come on, folks. Answer. Solid. Sure. Okay, and just like this is what we were doing before, and we're going to continue doing this when we get the other guys as well. So now we're going to go ahead and do our net ionic equation, and we're going to start with the solid. CaSO4 and solid. And we need a little underline so we can get the balancing. And now we're going to rip that guy apart, right? Rip them up. Yeah. Okay, so who's first? Calcium. Sure. What's the charge on the calcium ion? He's in column 2. 2 plus. Yeah, okay. Now this one you just have to know. I hope you know this guy after today. We just took a quiz on this. What's his charge? 1 minus. Good. And he is the what ion? Nitrate. Good. Okay, now we're going to look up and we're going to see, okay, there's my guy, and he has a coefficient of 1, so I put that down here. I see calcium up there with a coefficient of 1. Okay, there he is. And I see nitrate. Oh, what's his coefficient going to be? Oh, whoa, where are we? Nitrate's not in there. So who do we have over here on the left? Oh, sulfate is supposed to be here. Ay, ay, ay. I wrote the wrong thing. Okay. Shame on Wigger. Not that dude. Who should I have there? Sulfate, yeah. Sulfate ion. Isn't it nice to kind of know your way around the ions a little? Yeah, you don't feel like such a lummus. Know a little bit. Okay, so I'm gonna look for sulfate, and there's our sulfate dude, and the coefficient there off to the left is 1, and so that's gonna fix us up for that guy. And so we're going to put his coefficient as 1 for the sulfate. Let's see if I can get rid of that. Come on, here, get rid of you. Come on. Little box, go away. There we go. And so the next guy we want to have is, let's see, we did the sulfate for 1. And what's the coefficient for calcium? Come on, class. Are you awake? Come on. Yeah, coefficient is 1. All right. So now we have a balanced net ionic equation. That's all there is to it. It's really nice. You don't have to do the complete ionic equation. All right? Don't waste time doing that. All right. Water's formed when what two things come together?
Hydrogen and
Hydrogen ions and
Oxygen.
no. Hydrogen and
Hydroxide?
hydroxide. There we go. That's the hydroxide ion. Right there. Okay, hydroxide ion. So hydroxide ion is sitting over here, and when I write water this way, I can see hydroxide in water, which is very, very nice. So, yeah, we got hydroxide, and, now, what are we seeing here that tells us we have the guy for the net ionic equation? Is it the gas, precipitate, or liquid? What is it? It's the liquid, you bet. So let's circle that guy. And then we're going to come down here and do our net ionic equation. And it's going to start with the HOH. And this guy is a liquid, so we have to write that. And then we're going to go to the left side, and we're going to work that out. We're going to move that little label there. And let's put the hydroxide first. And there. And then we're going to put the hydrogen here. And that's H hydrogen, not H2 hydrogen. So he's a 1 plus. And all the coefficients are 1, right? Makes it easy. 1, 1, 1. This is how you're doing the acid-base dudes. Okay. Let's go and do one. Right out of your homework. Okay, I'm going to erase this stuff so I can kind of develop it for you. And we talked about where things come from and where they've been. And let's get this guy out of here for now. And delete. All right. What I've done for you on these guys is I've done the balanced equation, the whole thing, not just the skeleton, just to kind of shorten things up as we're doing the video. And notice the classifications that we have over here. Okay, we've got AV for what? Acid base, and what's DR? Double replacement. Good. Okay. You're getting a class response. Woo. All right. Now, do we have the gas, liquid, or a precipitate? What's going to drive this reaction? Liquid. Ah. Okay, so let's go ahead and circle liquid. And that means that water is produced. Now, once it gets into the rest of the solution, you can't recognize it. I mean, it's just water. So that's pure water. And that's what liquid means. It doesn't mean water with something in it. It just means pure water. So if I take my deionizer in the back room there where I can make deionized water, that's pure water. It has no ions in it. So we call that L, liquid. Has a specific meaning, that's all. All right, so I'm going to grab that guy, the HOH, and we're going to bring it in here. HOH, this should be looking very, very familiar. Yeah? Is this what we just did? Okay, I've got the water, and I've got the salt right there. That's what acid and base reactions do. Why is this a salt? Huh? Why is he a salt? What makes a salt? Metal and non-metal. Metal and non-metal. So potassium's our metal, and sulfate is made up of oxygen and sulfur, both of which are non-metals. Yeah? So we're good? Now let's take him back to the other side. Just like we did before, this should look very familiar. Look at your notes. Watch. And OH, the 2 parts of water, right? And let's see what the coefficient is of water. That's a 2, isn't it? let's see if I can get him over a little bit. Yeah. I love being able to do that. And so now we look at it and we say, okay, up here at the top, where we got him from, he has a coefficient of 2. So that means we have to have, on the other side, 2 hydrogens. Those 2 hydrogens are coming from the sulfuric acid. And the base solution that we had was potassium hydroxide. And that's where our OH came from. And we're looking at a total of 2 and 2. Oh my gosh! Can we change that? We have to. What do we change it to? 1. Yeah. Everything's 1 because all of the 2's can be divided by 2. And that makes 1 to 1, 1. That's our ratio for our balanced net ionic equation. Okay, there we go. These are the guys we're going to do next, and I'm actually going to show you those in just a second. But let's do the little example first. Okay, gas is formed. These are the 3 gases that could be formed in these reactions. So I'm not expecting you to be able to write these equations and complete it and balance it. I'm giving you the skeleton for all of them, and we'll see that in just a second. But for right now, once we've got this guy balanced, because I'm going to give you the skeleton, so this is the balancing. Now we're looking for, and remember this. That's where we want to look now. What do we have in here that is 1 or more of those? We're looking for gas, solid, and liquid. What do we have? Does this fit? Is that a gas, solid, or liquid? What do you think? Come on, think. Wake up! Come on! Does this fit? Is this going to be in the net ionic equation? This guy right here. Why? Because he's not gas, solid, or liquid. Okay? Who should I take? Water, absolutely. That's my liquid. So I'm going to go ahead and circle that. Do I have any others? Carbon dioxide, gas, you bet. Okay. So both of these are going into my net ionic equation. And this. All right, good. Now, I go down here, and I'm going to write these guys first. Oops.
Oh, I didn't get all of it.
Okay. So, I'm going to write my CO2, and that has a subscript of G for gas. And then I'm going to write my water, H2O, and then I'm going to go to the other side and break those guys up. So where'd my water come from? Here, let's get this guy so we can concentrate on this equation alone. Here we go. Oh, that's much better, isn't it? There we go. Far, far superior. Okay, so I got water and carbon dioxide on the right. Where did the carbon dioxide come from? Huh? Where do you think? Where's the only place that has carbon on the left side? This guy, right? Yeah? That's carbon, right? Okay, that's carbon oh, what's the name of that ion? Cl3 2-, carbonate. Right. Okay. So I'm looking there. I see the ion that I want. Get that to work right. There we go. And so I'm going to take that ion out. CO3, 2 minus. And that's part of my net ionic equation. Now, how about the water? What's that going to come from? It's going to come from this guy. And where else? Okay, the carbonate ion is going to donate an oxygen to the process. So we got 1 oxygen here and 2 hydrogens from here. And that's where that's coming from. And so now we just come back over here and we're going to write both. We got the hydrogen 1 plus, and we're going to have the hydroxide 1 minus. And so let's see what we have. How many hydrogens? How many hydrogens over here? 2. Okay, that balances this guy. And how many hydroxides? 1. So there were no hydroxides. There were no hydroxides over here, but the OH was made by an oxygen from here and the hydrogens from here. So that made the hydrogen ion, and one of the oxygens went with the other hydrogen, and that made the hydroxides. It was kind of an intermediate reaction. You think when you look at a reaction you're seeing everything? Nope. Lots of fun stuff's going on. Question? No. Okay. Just in your glasses. All right. So we have 1 hydroxide, and I really should write this as 1. Come on. Yes. I'm sorry?
Exactly does that work? Because then there'd be 4 oxygen. There's only 3
No,
oxygens.
there's an H2O. That's it. And that's a 1. And the carbon dioxide here. And so we have 1, 1, 1.
Yeah, there's 4 oxygens, but there's 3
No. There's 3 oxygens on the left. Okay? This gives you 2 oxygens and 1. 3.
It's not balanced.
It's not?
There's 4 oxygens on the left and 3 on the right.
there's 3 on the right.
We're,
On the bottom equation, the net ionic.
whoa. We're on the,
It's not balanced.
yes, carbonate. I'm off.
There's no hydroxide. There shouldn't be a hydroxide.
Okay, I just want to set something straight.
Here you go.
I was not thinking clearly, and these hydrogens do come from this guy, but the oxygen came from here. Okay? So that oxygen went to the hydrogens, and that gave us the H2O. Okay? So that's how that guy comes out at the end. Thank you very much for watching.